Hey guys, it's Shahir from 5 Academy. Hope everyone's doing well. So, today we're going to be going through a number of very difficult ACT math problems. The type of problems that you're going to see at the very end of the math test, and that typically require the most brain power and time. So, the goal here with this video is to help you understand how to answer these problems faster, to give you more exposure to the problems, and also give you an opportunity to try them and see how I will end up solving them and compare methods. So, what I'm going to recommend you do is don't just watch this video. As we go through, try each of the problems yourself and see what you get, see how far you get. If you get the right answer, great. That's an indication that you're going to probably be able to answer the questions at the end of the exam pretty well and successfully. But if you have trouble, that's fine too. That's actually quite normal given how difficult these are. Just watch the video as a way to learn the right methods and improve your skills. There's a finite number of skills that show up on the math test, so if you get some wrong and if you learn those skills, you're very likely to get those type of problems right next time. So it's not the end of the world. Take each problem one problem at a time, take it one skill at a time, and eventually you'll learn all the skills. Okay, so let's get started. Which of the following values of z will make this system have no solutions? So we have two equations here. And one of them has this value z, okay? Now, you might look at these equations and say, okay, how do these two have a solution? What is a solution? What do these equations look like? What are these? So really what these are lines. And how do you know that? Well, anytime you have an equation that has one independent term of x and one independent term of y, and no other xy terms or y squared or x squared terms, then, or no cosines or any other weird stuff, then that means that you essentially have a linear equation. And I can rewrite this in the form y equals mx plus b, okay? Which basically means just isolate the y. I can do that for both of these. So for the first one, let's do that really quick. I'm essentially, in order to isolate the y, I just got to get the x over to the other side. Negative x plus 1, right? And then for this one, I just got to get, again, same thing. Y equals negative x plus z. All right, and now let me just backtrack. Why did I do this? Knowing the equation and how it's written in y equals mx plus b format is usually easier for most students, and it's how you graph problems. So what you notice right away is that they have the same slope. The m value is actually going to be -1 for both. That means that the lines are parallel. If they have the same slope, they are parallel. So if I was to graph them with a slope of -1, they would look like what you see in blue here. They would look like something like this, right? They would be parallel. This is not a perfect representation, but it would look like this, okay? Now, in order to have no solutions, what does that really mean for two lines that are obviously parallel? It means that they have to never intersect. So when you have two lines, usually, you'll have maybe one with like a positive slope and another with a negative slope, and you'll have an intersection point. And at this intersection point, the y values and the x values are equal to each other, so you have a solution. And that reflects in the equations as well. If you plug in the x value, you'll get the y value for this exact point for both equations when you do it, okay? Now, if you want no solutions, you basically have to come up with two line graphs that have no intersection point. Given the fact that they're parallel already, you kind of, really anywhere that you put, this line, or either way, you'll have no intersection point unless you make them the exact same line. Then they are intersecting each other at every point. So basically what we want to do is make sure that z is not equal to this value, that the y-intercepts are not the same, okay? So if the y-intercepts are different, then you'll have no intersection points. And that's exactly what this answer option is. If I make, for example, let's say this equation, if I graph it, it's actually going to look like this, okay? Where this y-intercept is going to be 1. That's the b value, right? B equals 1, that's your y-intercept. So if I make a line like b, then I end up with all solutions. If I make a line like this, z is basically anything but 0. Sure, I'll get a bunch of lines that look like this, but I'll also end up having the possibility of a line where z is equal to 1. And if I make it equal to z equals 0, I basically get this line right here. So you want to make sure z does not equal 1. Let's move on. A circle with a circumference of 4 pi has an area of what? So circumference, what's the formula? 2 pi r, or pi times diameter, okay? Now, what's the formula for area? Area is equal to pi r squared. So if I want to take this, and it says the circumference is 4 pi, and I want to identify the area, well, I can just take this information here and solve for radius or diameter. So 2 pi r is equal to 4 pi. If I get rid of pi on both sides, essentially divide both sides by pi, I get 2r is equal to 4. That means r is equal to 2, okay? And then if I plug that into the area formula, pi times 2 squared, I end up getting 4 pi. Okay, so interestingly enough, the circle area and circumference are equal to each other. They're both 4 pi in this particular case. Okay, so basically what you're doing is you're just taking the information you have, applying a formula to it to extract what your radius / diameter is, and then you're reapplying that to another formula. Pretty straightforward. That one's a little easier. If you're looking for free ACT prep content, the5academy.com is your one-stop shop. From free tutoring with our experts to diagnostic quizzes, we have you covered. All you've got to do is head to the free link in the description, create an account which takes less than 2 minutes, and then access your dashboard where you'll find everything you need. The diagnostic quizzes you'll find there test you on every problem type you'll see, and the first one for each section is included in our free package. After you complete one, see the skills you missed, and head to the skill hub for that section to find a written overview teaching you about that skill. You also have access to extra math content specifically for formulas and properties that you'll be tested on in the math test. The dashboard also allows you to schedule a 15-minute free tutoring session with one of our student experts, as well as take 5 Academy practice exams straight from the site, with your mistakes and data filtering straight into your dashboard for further review and analysis by you. Again, this stuff is all free. Check it out and more in our free and paid courses. In this problem, 5 to the 125 is being divided by 625 to the 31. Okay, so how do you do this problem? Most straightforward approach is just to plug this into your calculator and divide it by this. But I think most calculators, they will not actually be able to take these numbers that are this big. It's like something times 10 to the 87th or something like that. So for a lot of calculators, that's just too big. It's not going to be able to process that. So you can't just plug it in and find the answer for most calculators, I think. What you're going to have to do is calculate it by hand. You can do that by using some exponent rules to make it a little easier. So what you can notice is that 5 and 625 are both exponents of 5. So 5 to the 1, for example, is equal to 5. 5 to the 4th is equal to 625. Okay, so this is something that you can use to essentially make the denominator a little easier to work with. And then essentially if you write both of these bases with a base of 5, then you can do some exponent rules to reduce the exponent and arrive at an answer that looks like this. So let's do that. So what I'm going to do is 5 to the, for this one, right, the base is already 5. So I don't need to do anything here. This is all good. But this guy right here, I'm going to rewrite 625 as 5 to the 4th. So let's do that. So 5 to the 4th, all to the 31, okay? So I just rewrote it. Nothing changed here. Now, there's an exponent rule that says if you have an exponent raised to a number, sorry, a base raised to an exponent, sorry, and then you have another exponent on top, the output of that is just multiplying the two exponents together, okay? So this would be a to the bc. You can do the same thing here. 5 to the 4th is raised to the 31. So I can multiply 4 times 31 and end up with, okay? So 5 to the 125 or 5 to the 124. Now, the other exponent rule that we're going to use is now that these are both written with the same base, since they're being divided, you can actually subtract the exponents and arrive at 5 to the numerator exponent minus the denominator exponent. So for example, a to the b divided by a to the c is equal to a to the b minus c. So 5 to the 125 minus 124 ends up giving you 5 to the 1, which is just 5. All right, so we solved this one using two key exponent rules. One is the multiplication of exponents when you have a base raised to an exponent raised to an exponent, and the second being the subtraction of exponents when you have the same base but two different exponents. All right, a cylinder has a radius and height of 1. A cube with what surface area has the same volume? Okay, so there's a few different things going on here. So the cylinder has a radius and height of 1. So volume of a cylinder, what is that formula? Pi r squared. Usually they'll give you this formula, so if you don't remember it, don't worry. And a cube with what surface area has the same volume? So what's the volume of a cube? It's just length to the third, right? The length times length times length. It's really length times width times height, but since for a cube they're all the same, you can just do length to the third. All right, so we want to find with what surface area has the same volume. Let's first find the volume that we're talking about in the first place. So volume of this cylinder is going to be radius is equal to 1, height is 1. Pi times 1 squared times 1 is equal to just pi. Okay, so your volume is just pi. That means your volume here is also just going to be pi, which means I can actually solve for the length, and that's going to help me actually here. The length is just going to be third root of pi, right? If I want to evaluate this expression right here, length to the third equals pi, I basically have to take the cube root of each, which is the same thing as doing this to the 1/3. So this and this are the same exact thing, just for as an FYI, but I'm not going to keep this here. I need the space to solve the rest of the problem. Okay, so a cube with what surface area? So now that we know the length of this, of each side length of this cube, we want to find the surface area. What's the surface area of a cube? How do you describe that? So if I look at a cube, right, just kind of high level, if you don't remember the formula, you basically have, I'm going to draw the back side of the cube too. If you count the sides of a cube, you have your left side, your right side, and I'm going to color code this to make it easier to mark. So you have your left side, your right side, you have your upside and your downside, and then you have your front side and your back side. So it's 6 sides total, each of them with the same surface area, okay? So now if I just take one of those, let's just take the front side, right? Side length L, what's the area of this? Area is just going to be L squared, right? And if I know I have 6 faces of this cube, the area of, so this is the area of one face, the area of the cube is going to just be 6L squared. Okay? That's the surface area of the cube, and I'll call it surface area, SA of the cube. Now, I know what L is, right? I can just plug this in here, and I get a value for surface area. Let's just do that. Surface area of the cube is equal to 6 times L, which is pi to the third root of pi. Here they write it as a fractional exponent, so I'll just write it as pi to the 1/3. That's your L, right? This is just, in this parentheses is L, and L squared is just going to be all that to the second. I can rewrite this as 6 pi to the, remember what I just talked about with exponent to an exponent? In that case, you multiply. So what's 2 times 1/3? It's just going to be 2/3. And that's your answer. All right, so weird problem, but testing you on a lot of those key skills, right? What are the key skills here? First, be able to evaluate and know what is the volume of a cube. That's something you need to know. The volume of a cylinder, they'll usually give you the formula, so don't worry about that too much. Then, identifying how many sides there are to a cube, identifying the area formula for a square, and then applying that to a cube in general, knowing how many sides there are, and then at the very end, plugging it all in, making sure your terms cancel out and you don't make silly mistakes like choosing answer option C. Square root of 7 all to the 8x is equal to 2401 to the 3y. So what is x times y? All right, so weird problem, but let's see what we can do to evaluate this. First of all, we have this square root of 7, which is really the same thing as writing 7 to the half. So what I want to do is get rid of this square root, and I want to rewrite this as 7 to the half so that I can multiply this exponent into the half exponent right there. So let me just, it's just a little cleaner. I don't like seeing radicals in there. I rather see only exponents across the board. It makes it a little easier and cleaner to solve, and I think it'll help us. Okay, so 7 to the half all to the 8x is equal to 2401 to the 3y. And I, just so you know, if you want to understand the exponent rule a little bit better here, go to the problem 2 problems ago. I did this, and I also did in the last problem. All right, so half times 8, that's going to give you 7 to the 4x is equal to 2401 to the 3y. Okay, now going back to that problem where I did 5 to the 125 over 6 to the 31, sorry, 625 to the 31, I ended up just taking the new denominator and seeing if it just, just identifying that it has the same base of 5 as the numerator. You'll notice the same thing here, actually. I think 2401 is an exponent of 7. So I think 7 to the 4th? Yes, 7 to the 4th is equal to 2401. So what I'm going to do here is just rewrite this as 7 to the 4th. 7 to the 4x is equal to 7 to the 4th all to the 3y. Now let's do the multiplication of exponents again. So we end up getting 7 to the 4x is equal to 7 to the 12y. That means that if the bases are the same, right, that means that the exponents have to also equal each other in order for this statement to actually be true. If I tell you a to the b is equal to a to the c, that means that b has to equal c. there's no way they don't equal c. If, like, for example, let's just plug in numbers, right? If I say 3 to the 4th is equal to 3 to the 7th, is that true? No, it's not. It's only equal to 3 to the 4th. So let's do the same logic here. This means that 4x is equal to 12y. And if I want to find what xy is equal to, let's just do this. I'm going to just isolate the x side of this. X is equal to 3y. And if I want to find xy, just multiply both sides by y. I end up getting xy is equal to 3y squared. Kind of weird problem, but what's the rule here? Again, let's go skill by skill and identify what it's asking you to do. First, know how to convert from a radical to an exponent. If you see square root, think of it's the same thing as what's inside the square root all to the half. If you see cube root, it's the same thing as whatever's inside to the 1/3. Okay, first rule. Second, actually applying the multiplication of exponents. When you have an exponent raised to another exponent, you can multiply the exponents. Then identifying that 2401 and 7 have the same base, doing the exponent rule of multiplication again, and then moving terms around and strategically multiplying and dividing by terms so that you can end up with the expression that you want at the end. You can manipulate an equation however you want, to isolate terms however you want. As long as you're actually able to do it, you're going to arrive at the right answer. So you got to be creative with these. It helps with practice, and you'll get it as you practice it more and more. What is the midpoint of the following 3 points? Okay, how do you find midpoint? What you should do, there's a formula for it. I'm not even going to tell you the formula because it's not really that helpful and it's confusing more than anything. Essentially what you're doing, think of it in terms of you have, for each coordinate that you're given, you have x values and you have y values. Okay, let's start with the x. It's really two separate problems. One problem, half of the problem is for the x side, the other is for the y. We're going to start with x. So my x values are a plus 3, and then a plus 3 again. What you want to do when you're finding midpoint is for each half of the problem, right? For the x side, for example, you just want to find the average. So what's the average of these three numbers? You might think, I don't know what the numbers are. How can I find the average? Well, the way you find the average is by, again, what's the formula for average? Average is equal to sum divided by number of numbers. So let's just do that. Let's just take the sum and divide by the number of numbers. Divide by 3. 3 numbers, right? Let's just keep simplifying it. Just keep going. Even though you might not end up at a numerical answer, just keep going. I get 3a plus 6, right? Divide by 3. And then that ends up giving me, I can divide 3 by 3 and 6 by 3. I end up getting just a plus 2. All right, this is my x bar, I'm going to call it. This is my average x value. Okay? So that's my x midpoint of these 3 points. No matter what the value for a is, this is going to be the midpoint for those 3 points. Let's do the same thing for y. So what are my y values? B plus 3, and b. So b plus 3, and b. Average is equal to sum divided by number of numbers. That's equal to b plus 3 plus b divided by 3. It's equal to 3b plus 3 over 3. That's equal to b plus 1. That's it. So this is my my midpoint is going to be a plus 2, comma, b plus 1. That's it. That's my x bar, comma, y bar. That's the best way to think of midpoint problems. This one's a little bit more challenging, conceptually confusing because you're not given actual numbers, but that's okay. Who cares, right? 64% of 625 over 4 is what proportion of 333? Okay, so what is this saying? There is a way to kind of think through these word explanation math problems where they describe the problem to you instead of just writing out the equation and telling you to solve for it. So a key thing is when you're given something is a percent of something else, that means multiply, right? That means multiply the decimal equivalent of the percent by that number. So what's the decimal equivalent of 64%? 0.64, okay? So keep that in mind. This number, whatever it ends up being, that's what we're going to end up multiplying this by. All right, now another thing to keep in mind, when you see is, that just means equal to. Okay, so we have 60, let's just start constructing it. 0.64 multiplied by 625 over 4 is equal to what proportion of 333? So what proportion, whenever you see what proportion or some proportion or some value, you can just plug in x, okay? Now, given that it's a proportion, that means that we're also going to be multiplying. Multiplying that unknown x value by 333. Okay? So now we have an equation. Let's go ahead and solve it. So 0.64 times 625 divided by 4 gives me 100 exactly, which is kind of nice, times 333x. Clearly, I just want to divide by 333. X equals to 100 divided by 333. I end up getting 0.3003. It's kind of just this repeating, which is approximately equal to 0.3, okay? Now, what proportion? Now, obviously, my answer is 0.3. None of the answer options are 0.3, so what do I actually do? Now, remember how we converted from a percent to a decimal? If I have a percent like, 35%, the way you convert it to a decimal is you take this decimal that's here and you move it 2 places to the left and you get 0.35. These two are equal. Okay? Now here I have a decimal, 0.3, or you can call it 0.30. To convert that to a percent, it's going to be equal to 30%, because I moved the decimal 2 places back to the right to get that percent. So again, percent to decimal, you go 2 places to the left. Decimal to percent, you go 2 places to the right. All right, so we went 2 places to the right. We got 30%. That's my answer. So what are the key skills here? First, knowing how to convert from a percent to a decimal. Then multiplying, right? Knowing that 64 some percent of a number is just multiplication. Then knowing what is means is equal to, and then doing a proportion, multiplying those two things. And then just solving the problem and knowing again how to convert back to a decimal. Those are the key skills here. You're doing a multiple choice test. Each question has 4 options. There are 5 questions on the test. So what's the probability that you get all of them wrong? Okay, so the probability of getting a question right is equal to what? It's going to be, each question has 4 options. So it's just going to be 1 out of 4, right? One of them is correct. That's the assumption we're making here. That means that the probability of getting a question wrong is equal to 1 minus 1 over 4, which is just going to be 4 over 4 minus 1 over 4. It's equal to 3 over 4. You can also conceptually understand this by just knowing that there are 3 incorrect answer options, right? So, but yes, remember that. Yeah, so just remember these 2 formulas for now, okay? Now, we're asked, what's the probability you get all 5 of the questions wrong? So when you have a repeated event like this that has the same probability for each event, or if you know the probability of each event and you're just trying to find what's the probability that I get this specific combination of events where I get all of them wrong, you can just multiply the probability of each event by the other associated events. So we're going to multiply, so probability 5 wrong is just going to be equal to 3 over 4 times 3 over 4, 3 over 4, 3 over 4, 3 over 4, which is really just equal to 3 over 4 to the 5th, right? That's equal to 3 to the 5th over 4 to the 5th. That's equal to 243. If you do it on your calculator, divide by 512. So your answer should be, hold on, let me just double check 4 to the 5th. It's actually 1024. So there's a pretty good chance that you get all of them wrong. It's about a quarter, right? You see this? If you do the math there, 243 divided by 1024 is equal to 23.7% chance. So just keep that in mind. But yeah, that's how you do these. Again, what's the skill here? Knowing how to determine a probability, knowing how to determine, again, a probability, and then knowing how to multiply probabilities by each other or by other probabilities for a combination of events. Again, let me just give you one more thing. This is called the AND probability. So probability of event A and event B. Again, let's say that there are 2 independent events. It's just going to be probability of event A multiplied by probability of event B. In this case, we have 5 different events. All of them happen to have the same probability. So it's just looking like we're multiplying 3 over 4 by itself 5 times, which really we're doing, but we're also just doing this. But there's a few more AND statements, a few more multiplications, and it's the same thing. 3 cubic miles is equal to how many cubic kilometers? So there isn't really a good, 3 cubic miles is equal to how many cubic kilometers? So where you're going to start with on this one is the conversion factor for miles to kilometers. So 1 mile is equal to 1.6 kilometers. And what you can do is quite literally just cube each of these. Take it to the 3rd power. that gives you 1 mile cubed is equal to 4.096 kilometers cubed. This is a true statement, and that's your conversion factor. You just found it by cubing them. And you can just multiply by 3. You end up getting 12.2288 kilometers cubed is equal to 3 miles cubed. It's really that simple. They don't give decimals in this problem, but it's really that simple, okay? Now, the reason some students might get tripped up by this one is you might think to use the whole conversion factor formula, which looks something like this. So let's just say you wanted to convert 45 miles to kilometers. So the way you do that is you'd say 45. I have 45 miles. I'm going to multiply by some conversion factor, and that's going to give me some X number of kilometers. Okay. The conversion factor is just whatever your this is the conversion factor. So we know that 1 mile is equal to 1.6 kilometers. What you do is you put your desired unit in the numerator. You put your old unit in the denominator, and then you just have a fraction essentially to solve. So 45 times 1.6 over 1 is equal to the number of kilometers. That gives you 45 times 1.6 is 72 kilometers. Okay? That's essentially how you do this problem. Now, if let's say we were asked, okay, we want to go from 45 miles cubed to some kilometers cubed, you can just take this to the third power. Sorry, not the whole thing, but it's going to be 45 miles cubed. And you're going to take your conversion factor, but instead of leaving it as is, you're going to take it to the third power, right? Because what did we do before? 45 miles times 1.6 kilometers over 1 mile. What happens here is the reason you get an answer in kilometers is because miles divided by miles is just going to be 1. There's no unit left. You're only left with kilometers as your unit. If we're starting with miles cubed, we need to end up dividing this by miles cubed. This exponent of 3 is going to distribute down to kilometers and miles, and you'll end up with a unit of just kilometers cubed. And this is going to be your answer. That's the way you do this problem. If you want to go from 3 miles cubed, that's the way you do it. You go from 3, your math essentially looks like 3 times 1.6 to the third over 1 to the third is equal to whatever I just told you, 12 something. All right, let's move on. 3 over 2 times cosecant of 2 over 3x. All right, so what's the period of 3 over 2 times cosecant of 2 over 3x? So what is actually happening here? What is cosecant? So cosecant of x, for example, is equal to 1 over sine of x. We know that for equations like cosine, sine, right, the period is equal to 2 pi over b, where b is your value essentially in front of the x. So if you have sine of 3x, b equals 3, and you'd plug that in here, you'd get a period of 2 pi over 3. If you have cosine of 1 over 6x, or that's equal to cosine of x over 6, your b is equal to 1 over 6, so your period is equal to 2 pi divided by 1 over 6, which is equal to 2 pi times 6, which is equal to 12 pi. Okay? Now, this rule, period equals 2 pi over b, carries over to cosecant and secant, which means that my value here of b is going to be 2 over 3. Period is going to equal 2 pi over b, which is 2 over 3. This is kind of hard to solve. You can do it by calculator if you want, but the way to do it by hand that's pretty straightforward is, remember that dividing by a fraction is the same thing as multiplying by its reciprocal. 2 pi times 3 over 2 is equal to 3 pi, because the 2's cancel out. All right, this is an example. This type of problem is exactly what will show up in the last 10. A very good example, just completely spun off from from actual practice official tests. So keep this one in mind. Which of the following is irrational? So what does that mean? Let's assume you don't even know what this means. Let's just see which of these kind of looks the most unique. All right, so square root of 4 is 2. Square root of 81 is 9. This is a never-ending decimal, so I think 0.2 repeating. Square root of 81 9 over 4 is equal to, I think it's 2.25. Square root of 5, you can't actually simplify that. This just ends up giving you square root of 5, which is a never-ending decimal as well. 2.23, yada, yada, yada. 5 over 4, or sorry, 5 over 8 ends up giving you 0.625. 12 over 3 ends up giving you 4. Okay, so which one of these is most unique? Well, this is a never-ending decimal. This is a never-ending decimal. This is an ending decimal. This is an ending decimal. This is just a whole number. But the one that sticks out the most, I mean, there's commonalities across these. This one has a square root. So, and you can't get rid of it. The others, you could get rid of the square roots. All the others. You see 10 of them here. You got rid of 9 of them, but you couldn't get rid of that one there. For that reason, this number is irrational. Irrational, the actual definition, is a number that cannot be written as a terminating decimal, or essentially a number that you can't take away that radical from, the radical being that square root symbol. There's no other way to write it. You have to write the number with that radical. Or other examples are numbers like e, I, pi. Those are irrational. So in this case, since you can't rewrite this without that radical, it's going to be irrational. But if you don't know what irrational means, or if you forget, just look for which of the answer options kind of looks the most unique. And in this case, it's C. To increase the mean of 10 numbers by 10, the sum must increase by what? So the mean of 10 numbers, we're trying to increase it by 10. And there are 10 numbers. So let's use a model or a formula that helps us actually understand what's going on in this problem. So to increase the mean of 10 numbers, what's the mean formula? So the average of some set of numbers is going to be the sum of the numbers divided by the number of numbers, right? So if I ask you the average of 3, 3, 7, and 5, you're going to add them up and divide by 4 because there's 4 numbers, right? So now in this problem, I'm going to just say the average is equal to x bar, right? Forget the word average, just remember x bar. So the original x bar original, I'll call it original, is equal to those 10 numbers, the sum original, divide by 10, okay? Now, if I want to make x original, my x bar new, is going to be x original plus 10, right? I want this new average to be 10 greater, right? That's why I added 10 here. So x bar new is going to be sum original over 10, right? Which is just x original plus 10. Okay, so just understand what I did really quick. I wrote my original state, I wrote an equation that dictates my new state, and then I just plugged this guy into here. And that's what I got here. Okay? That's all I did. So let's now work off of this. X bar new is equal to, now I want to find my sum, my new sum, right? The sum must increase by what amount of numbers? What I can do is just combine these two, combine this fraction with the number 10. And the way I can do that is just write sum original over 10 plus, how can I make 10 have a common denominator with 10? We'll just write it as 10 times 10 over 10, or just 100 over 10. This gives me sum original plus 100, both divided by 10. And I can combine now. Over 10. And this is all equal to my new average. And this really tells you the answer. I have to take my original sum, add 100 to it, and divide by 10, and I get my new average. Your answer is 100. Now, if you're not sure what to do here, you can just plug in numbers and just do it that way. Let's do that. Let's say my set of 10 numbers is just 0. It's just 0. All of them are zeros. Okay? And if I want to increase the average by 10, so I want to increase the average to 10 from 0, what does the sum have to increase by? Well, if I have a bunch of zeros, right, my x original is going to be 0 over 10, 0. My x bar new is going to be, should be 10, right? We know that for sure. And that has to equal, basically, it has to be 100 over 10, right? We know that for sure. So your sum has to go from 0 to 100. All right, that's basically it. This is just your sum, the sum, right? The sum is what's in the numerator of the average formula. Hopefully that made sense. Again, just trying to give some light to that. How many zeros does this number have? Okay, you can try plugging that into your calculator. Your calculator is not going to have it. So what you can do is, let's just look at 100. 100 has 2 zeros, right? Now, if I take 100 to the second, how many zeros does that have? Well, it becomes 1, 0, 0, 0, 0. If I take 100 to the third, how many zeros does that have? 1, 0, 0, 0, 0, 0, 0. Okay? So, and I'm just going to check on my calculator. Yep, it aligns. So what I see is the number of zeros is just equal to the exponent times 2. Okay? So in this case, my exponent is here. If I just take that, multiply it by 2, I have my answer. Now, it looks like none of the answer options match what I've just said. So what's 100 to 100 expressed as one of these? 10 to the... Oh, I get it. I see what's happening. So the answer options are bringing it all to a base of 10. So if I write 100 with a base of 10, so let's just take this, right? This little part in parentheses. 10 to... So 100 is equal to is 10 to the second, right? If I just replace 100 with 10 to the second, take that to 100, I end up getting 10 to the 200. So it's going to have a number of zeros that's equal to 2 times 10 to the 200. That's that right there, okay? Again, the number of zeros is equal to, what are we doing here? We're finding a pattern, then we're applying it to the situation we're given, and then we're manipulating this with exponent rules. So there's a few different skills that are really taking place, and then you have to remember to keep that 2 and multiply that at the end, because the number of zeros is 2 times the exponent. And it's interesting, they made us rewrite the exponent here from a base of 100 to a base of 10, probably just to add extra difficulty, but that's what they did, and here it is. All right. This is the 560th digit of this never-ending decimal. Okay, so if I write this out, obviously it repeats forever, right? It keeps going. It's impossible to write this out to the 560th digit. It's going to take way too long. But what you do notice here, the way I've written it out, is that every fourth digit, you get 8. Obviously, you can't really say that about any other number, right? You can't say that every second digit is 3 because you have 3, but then you have 8. Then you have 3, then you have 8. You can't say that every third digit is 2 because 2, then 3, then 1, then... But every fourth digit is going to give me 8. So fourth digit is 8. 8th digit is 8. 12th digit is 8. 16. 20. You see that every time you jump 4, you end up exactly at 8. Any time I have a number, so you can think of any number divisible by 4, right? Like 400. Okay, the 400th digit is for sure going to be 8. So if I can just identify if this is divisible by 4, I should know if I'm going to end up at 8. And I do. I end up at 8. Okay. Now let's say they had asked you, what about the 562nd digit? What would you do then? Because 562 is not divisible by 4. But if I know that the 560th digit is 8, that means that 561 is here, and 562 is going to be 3. Okay, so that's how you can solve that. And again, the way that you extrapolate this, because this is a common problem, so you need to know how to approach this. The way you extrapolate this to, like, let's say I had written it out, the decimal as 1, 2, 3, 4, 5, 6, 7 instead. So now here you have 7 digits under that bar instead of 4 here. You can actually just do the same problem, but instead of checking for divisible by 4, now you're checking for divisible by 7. So if I asked you, what's the 700th digit here? Yep, it's just going to be 7. But if the 704th, then yeah, it's going to be 7, and you go 4 more digits. You can do the same thing with, like, if they ask you about days. So today is Monday. What day is it 200 days from now? Well, I know that every week is 7 days. So every 7 days, you're going to end up at Monday. So if I'm asking you for, 200 days from now, check if 200 is divisible by 7. If it's not, find the closest number to 200 that is divisible by 7, and then go a few digits to the right or left from that day that is divisible by 7. Okay? Hopefully that makes sense. In the equation here, the m and n are integers. The only possible x value is 4. So what is m? Well, okay, you immediately think, let me try plugging this in. X squared, if I just plug in 4, right? 4 squared plus m times 4 plus n is equal to 0. 16 plus 4m plus n is equal to 0. you haven't really, there's no way to solve this. How do you actually do it? So here's what you do. Okay, you conceptually solve it. We're given a quadratic, and we're told the only possible x value for when this y value, remember, this is usually equal to y, but it's saying when y is equal to 0, the only possible x value is 4. It's telling you that 4, 0 is a point, and it's the only possible value of x when y equals 0. That's important because you remember, this is a quadratic equation. It's the a value is a positive 1, so it opens up rather than opening down. It's going to look something like that. Only possible x value at only, really it's saying only y-intercept. Only x-intercept is 4. So can you identify for me what quadratic equation looks like this, where you have only one x-intercept? Well, remember how we do factoring, right? So if I give you an equation that's factored out like x plus 1, x minus 1, and I say, this is equal to 0, right? What this is really describing is the x-intercepts. There's two of them, x equals -1, x equals as equal to 1, because when you solve for x plus 1 equals 0, you end up with x equals -1, and same thing here, right? This is what it's describing, the x-intercepts. So the problem, really what it's telling you is you have one x-intercept instead of 2. And when you have one x-intercept instead of 2, it's actually a repeating x-intercept. Sorry, it's going to be x minus 4 because it's a positive 4 as your x-intercept. So this is actually your equation, and it's saying it's equal to 0. So your equation is x squared minus 8x plus 16. Not that that's important for this one, but what is m? Well, actually it is important because you need to find m and n. You see that m is equal to -8. Okay, so what did we do here? We conceptually remembered that this you need to catch this. You need to catch that it's telling you it's when y is equal to 0, your x value, that only possible x value is 4. As opposed to many other quadratic equations where it might look like this, you have two possible values for x-intercepts. But here it's telling you there's only one, so you know your equation has to be based off of x minus 4. That's exactly what we did here, and we ended up with this. That's it right there. All right, so that's all the hard problems that we're going to go through for this particular video. Hopefully it was helpful and you got something out of it at least. So I recommend, again, if you struggled with some of these, there are lots of resources that you can use, like our website, like other websites, like the ACT Prep Guide, etc. Take lots of practice exams. Use a resource that helps you learn the skills. Our website, like I mentioned, has problems specific to every single skill on the math test, and we go through them. We describe them to you. We have videos for each and every one. You can learn all these skills on our website. So check it out. There's free content there as well. There's paid content that's a little more helpful, and that'll probably help you improve your score a little more easily, but with some work. So hopefully this was helpful again, like I said, and we'll see you in the next video. Peace.